In this video, we will be discussing about the product rule from derivatives, and we will also be solving a few questions based on that. And the questions that I am discussing in this video, I have taken them from the Maharashtra Government textbook, Maths Part 2, 11th Standard. So let's begin. Now see, say for example, you have an expression of the type derivative of u plus v or u minus v. In both these cases, you can split the derivative and write it as d by dx of u plus or minus whatever you have, d by dx of v. But in case if the two functions which you are given are not getting added or subtracted, but they are getting multiplied, that is derivative of u into v is what you have, then in these circumstances you write the expansion for this as u into derivative of v plus v into derivative of u. Take one function, multiply it with the derivative of the other function. Take the other function, multiply it with the derivative of the first function. That is how the product rule is going to work in derivatives. Now say for example it is not 2 but it is a combination of 3 functions. So you are taking a derivative, that is d by dx of u into v into w. So this can be done in a similar way, that is you keep two terms outside the derivative and inside the derivative you keep the third function and repeat that thing for each and every function that you have. That means you have to do u into v into derivative of w. Now that you have taken derivative of w, take the derivative of v in the next term. So you will take dv by dx, but when you are taking dv by dx, you will multiply it with the remaining two functions, that is u into w. And you can add to it, again now you have taken dw by dx, dv by dx, so now you can take du by dx, that is derivative of the leftover function. And while writing this, you will multiply it at the beginning with the first two, the other two functions, that is v into w. So derivative of uvw, that will be uv derivative of w plus uw derivative of v plus vw derivative of u. That's how you can apply the derivative, that's how you can apply the product rule for 3 functions, if at all you have 3 functions. Okay, so with that, let's take a few questions. It's the second question, I think from exercise 9.1 or 9.2. Whichever one it is, you can just check. I have mentioned that I've taken them from the Maharashtra Government textbook. So yeah, let's go ahead with taking a derivative of this. So we have y as x power 5 into tan x. We take a derivative on both the sides. So the left hand side becomes dy by dx. On the right hand side, you can say that it is d by dx of x power 5 into tan x. So this is like derivative of u into v, and because it is derivative of u into v, we will write that expansion, the expansion of this right hand side as u, that is x power 5 into derivative of v, that is d by dx of tan x, plus v, that is tan x, into d by dx of u, that is x power 5. This will be x power 5. Derivative of tan x will be sec square x, so we have x power 5 into sec square x plus tan x into derivative of x power 5, and derivative of x power 5 can be calculated by the x power n rule. The derivative of x power n was n into x power n minus 1. So the derivative of x power 5 will be 5x power 5 minus 1, that is 5x power 4. And yeah, this is the final expression for dy by dx. Similarly, you can take a derivative or find the derivative of the second question. If I take a derivative on both the sides, then on the left hand side I will have dy by dx, and on the right hand side it will be d by dx of x cube into log x. Again, the right hand side is of the type u into v. So if you expand that right hand side, you will have u into derivative of v plus v into derivative of u. So we have x cube, derivative of log x will be 1 upon x, but then x cube into 1 upon x, that will be equal to x square. I'll write that directly. Plus we have log x, the whole thing multiplied by the derivative of x power n, that will be n into x power n minus 1. So that will be 3x square. And yeah, that's how we are writing the dy by dx expression for the second question. Moving on with the third one, it is a similar one, but just before you take a derivative, ensure to see that you are expanding this bracket. So if you expand that bracket, you have x power 4, that is x square the whole square, which is x power 4, plus 2 into x square, that is 4x square, plus 2 square, that is equal to 4 into sin x. So now when you take a derivative on both the sides, the left hand side will be dy by dx. On the right, it will be d by dx of x power 4 plus 4x square plus 4 into sin x. You can treat this term as u. You can treat this term as u, this term as v, and now you can expand the right hand side bracket as u into derivative of v plus v into the derivative of u. Okay, I have a little space at the bottom now, so I'll write that entire derivative in the last little space that I have here. So we have x power 4 plus 4x square plus 4. The derivative d by dx of sin x will be cos x. So we have the first bracket, that is this, multiplied with the derivative of sin x, that is cos x, plus we have sin x, the whole thing multiplied by derivative of this. Now derivative of this term, you can split that derivative, and a derivative term goes with each of the terms that are there inside the bracket. So the first term will be derivative of x power 4, that is 4 x power 4 minus 1, that is 4x cube, plus d by dx of 4x square. 4 comes outside the derivative, and then derivative of x square, that will be 2 into x power 2 minus 1, that is simply 2x. But that 4 and the 2 from 2x get multiplied, that will give you 8x. So finally the derivative of 4x square will be 8x, and finally plus the derivative of 4. The derivative of a pure constant was 0, so we have plus 0 in the end. So you can simply write it as 4x cube plus 8x, and yes, this is what will be the final expression for dy by dx for the third question. Going ahead with the fourth one, so we have dy by dx, we straight away take a derivative there, which will be equal to d by dx of e power x into log x. And just like we've been applying in the previous questions, the first term as u, the second term as v, and we can say that the expansion of the right hand side will be u into derivative of v plus v into the derivative of u. So this is e power x, derivative of log x, that will be 1 upon x. So e power x into 1 upon x, that's like e power x upon x, plus we have log x, derivative of e power x will be e power x only, so into e power x. Now at times, some places in certain questions, okay, in certain questions the e power x term is taken out common, and the final answer is written as e power x into 1 upon x plus log x. It is absolutely fine if you stop it here, but because one of the terms was e power x will be common to the first and the second term, and that is why in many questions you will see that that e power x is taken common. So this is how we will write the final answer, that is, this will be the final value of dy by dx for the fourth question. Moving on with the fifth one, this time it is a combination of three terms, so we have u, v and w. So when we take a derivative on both the sides, the left hand side will be dy by dx, the right hand side will be u into v into derivative of w will be 1 upon x. I am writing it directly, okay. So, okay, if I have to write it stepwise, it would be d by dx of log x, and then d by dx of log x will be 1 upon x. But now that you have practiced so many questions, I am sure that you might be comfortable in writing it directly. X power 3 by 2 into 1 upon x, that's like x power 3 by 2 upon x, and x is like x power 1. So a power m upon a power n, that is a power m minus n. So this is x power 3 by 2 minus 1, and 3 by 2 minus 1 is half. So we have x power half, and that is our first term. Keep in mind we took the derivative of w here. For the second term we will have x power 3 by 2, that is u, into w, that is log x, into This time we will take the derivative of v, but v is e power x. So derivative of e power x, and the derivative of e power x will be e power x only. So we write that term as e power x, and plus in the last term we will take the derivative of u. So we have v, that is e power x, w, that is log x, into the derivative, that is d by dx, of x power 3 by 2. But the derivative of x power n, the derivative of x power n is n into x power n minus 1. But 3 by 2 minus 1, that will be 1 by 2. And the last term entirely, this becomes 3 by 2. Let's just write it again. So 3 by 2. We got x power half. And then we had e power x into log x. So this is the final expression of dy by dx for the fifth question. Moving on with the sixth one. Now every time you need not blindly start taking a derivative. There are certain cases where you have terms of this type also. Now see, e power x cube, you can actually write it as x cube into log e. I am using the result log of a power m can be written as m times log a. So whatever you have in the power can be taken outside the log and can be written outside here. So I have x cube as the power and I can take it outside log e and write that first term as x cube into log e. But the value of log e will be equal to 1. So we simply have x cube into 1, and that is why the first term is only and only x cube into log of x cube. Again, that 3 can be taken outside the log and the second term can be written as 3 times log x. So into we have 3 times log x. Let that 3 remain at the very beginning. So we have 3 into x cube into log x, and now take a derivative. So on the left hand side it will be dy by dx, and on the right hand side it will be d by dx of 3x cube into log x. 3 is a constant and it can be taken outside the derivative. And now the entire function is of the type derivative of u into v. So dy by dx will now be equal to 3 into derivative of uv, so that will be u into derivative of v plus v into the derivative of u. D by dx of log x, that will be 1 upon x, but x cube into 1 upon x, that will be x square. So the first term is x square. D by dx of x cube, that will be n into x power n minus 1, that is 3x square. So the second term will be 3 times x square log x. So plus we have 3 times x square log x. Now at the most, if you want, you can open up the bracket here. So when you open up this bracket, you will have 3x square plus 9x square into log x. And that is the final expression for dy by dx. Let's go ahead with the next question. Here it's again the same rule, but just the sum is going to be a bit lengthier than the first 6 sums that we have taken in this video. So if we take a derivative on both the sides, we have dy by dx. That will be equal to d by dx of x square into root x plus x power 4 into log x. X square into root x. X square into root x. Root x is x power half. So x power m into x power n, that will be x power m plus n, and 2 plus half will be equal to 5 by 2. So the first term here, that is x square into root x, that becomes equal to x power 5 by 2. And yeah, after writing that term as x power 5 by 2, we can split the two brackets. If you open up the bracket, one derivative term attaches itself with this, and the derivative will get attached with the second term also. So the second term will be d by dx of x power 4 into log x. Derivative of the first term, this will be of the type x power n, right? So we have the derivative as n into x power n minus 1. So 5 by 2 minus 1, that will be 3 by 2, plus d by dx of u into v. So that will be u into the derivative of v plus v into the derivative of u. And yeah, with that we go ahead with our further expansion. So we have 5 into x power 3 by 2 divided by 2. X power 4 into d by dx of log x. D by dx of log x is 1 upon x. X power 4 into 1 upon x will be x cube. So that's your second term. The third term will be log x. That has to be multiplied with the derivative of x power 4. The derivative of x power n, that will be n, x power n minus 1. So we have 4x cube as the derivative of the second term. So we have 4x cube into log x. And yeah, that's how you are writing your third term. And this is the final expression of dy by dx for the first question in the third main question. Moving on with the next one. Again, take a derivative on both the sides. So we will have dy by dx equals to d by dx of e power x into sec x minus x power 5 by 3 into log x. So you can split the derivative, and one derivative goes with the first term minus the other derivative will go along with the second term. Okay, so we are just using the property that derivative of a minus b will be derivative of a minus derivative of b. And for both these terms, you can now use the UV rule. So e power x into sec x, that's like u into v. The derivative is going to be u, that is e power x, into d by dx of sec x plus v, that is sec x, into d by dx of e power x. Let's complete these terms for now. D by dx of sec x will be sec x into tan x plus d by dx of e power x will be e power x only. Now from these two terms you can pull out e power x into sec x common. So when you pull out e power x into sec x common, you will have e power x into sec x. In the first term you will have tan x left with you, and from the second term already you have taken out everything. So you will only be left with a 1 as your second term, minus the derivative of this entire term needs to be written. So you have u into v. So we have x power 5 by 3, that is u, into the derivative of v, plus v into the derivative, that is d by dx of x power 5 by 3. D by dx of log x will be 1 upon x x power 5 by 3 divided by x, that will be x power 5 by 3 minus 1, and 5 by 3 minus 1 is like 5 by 3 minus 1, that would be 2 by 3. So the power of x becomes equal to 2 by 3, plus we have log x, and that needs to be multiplied with the derivative of this. So we have 5 by 3 into x power 5 by 3 minus 1, that is x power 2 by 3. If you want, you can still pull out x power 2 by 3 common, and that will leave you with 1 plus 5 by 3 log x. So we have pulled out x power 2 by 3 common from here, and yeah, this is the final expression for dy by dx, and that's the final expression of dy by dx for the second question. Going ahead with the third one. So we have dy by dx. If you take a derivative on both the sides, the left hand side will be dy by dx, and on the right hand side it will be d by dx of x power 4 plus x root x. This is like x power 1 into x power half, that will be x power 1 plus half, that will be x power 3 by 2. So x root x will be written as x power 3 by 2. So we have d by dx of x power 3 by 2 into cos x, minus we have d by dx of x square into e power x. So now dy by dx becomes equal to d by dx of x power 4 and derivative of x power n, that will be n into x power n minus 1, so 4 minus 1, that will be 3, plus d by dx of u into v, so that will be u into the derivative of v, but d by dx of cos x, that will be minus of sin x, So we have x power 3 by 2 into minus of sin x plus v, that is cos x, into the derivative of x power 3 by 2. But again the derivative of x power n, that will be n into x power n minus 1. So 3 by 2 minus 1, that will be equal to 1 by 2. Minus, let's continue it in the next line. We have d by dx of x square e power x. So that will be d by dx of u into v once again. So this will be u, that is x square. Let's write it in a bracket. Into d by dx of v, that is e power x. D by dx of e power x will be e power x. Plus we have v, that is e power x, into d by dx of x square, and d by dx of x square, that will be n into a power n minus 1. I mean n into x power n minus 1. That will simply be 2x. So from these two terms again you can pull out the e power x term common. So we will be left with x square plus 2x into e power x. So minus, we have I'll write it here, minus e power x into x square plus 2x, and that is the final expression for dy by dx for your third question. Going ahead with the fourth one, dy by dx. So it will be d by dx of a minus b plus c. You can split the derivative and write it as d by dx of x cube minus 2 into tan x minus d by dx of x cos x plus d by dx of 7 power x into x power 7. So dy by dx will be, let's differentiate this term first. So the derivative would be u, I mean this is u and this is v. So the derivative will be u into the d by dx of v, that is d by dx of tan x, which will be sec square x, plus tan x into d by dx of u, that is d by dx of x cube minus 2, d by dx of x cube, that will be 3x square, minus the derivative of 2. Derivative of a constant will be 0, so we have minus 0. So 3x square minus 0 will be 3x square only. Keep in mind 3x square is not multiplied with x, it is multiplied with tan x. So a better way to write it would be 3x square first and then tan x, so that we are keeping ourselves free from all the confusions that can arise, that is whether it was x into 3x square or 3x square was multiplied with tan x. The right thing is 3x square was multiplied with tan x, and that is why we are writing it at the very beginning. Let's continue with taking a derivative of the second term, that is minus d by dx of x cos x. So minus, let's keep it in a bracket, u and v. So we have x into derivative of cos, which is minus sin x, plus cos x into derivative of x, which is equal to 1. So this becomes minus x sin x plus cos x. You can open up the bracket right here. So that will give you plus x sin x minus cos x. And these two terms we can write them here only. So plus x sin x minus cos x. And then we can continue with taking a derivative of the final term here. So consider this as u, consider this as v. So we have u into the derivative of v. Derivative of x power 7, that will be 7 into x power 6, plus we have v, that is x power 7, into the derivative, that is d by dx of 7 power x. D by dx of 7 power x, that will be 7 power x into log 7, and yes, this is what is the final value of dy by dx for the fourth question. Let's go ahead with the fifth and the last question, last question in this video. So we have dy by dx, we are taking a derivative on the left hand side. On the right hand side it will be d by dx of this plus this minus this. So that will be d by dx of the first term plus d by dx of the second term minus d by dx of the third term. Let's do this quickly, because now that we have solved so many questions, I'm sure that most of you might have been now in the position where you can answer these questions orally. So it will be u into the derivative of v. So it is, derivative of uv, that will be u into the derivative of v. So the derivative of v will be derivative of log x, that is 1 upon x. So we have sin x the whole upon x plus v, that is log x, into the derivative of sin x, which is cos x. So it is log x into cos x plus the derivative of this. So that will be u into the derivative of v, that is e power x into minus sin x, plus v into the derivative of u, that is cos x into derivative of e power x, which is e power x only. From these two terms, if you pull out e power x common, you will have e power x into minus sin x plus cos x minus, let's keep the derivative of these two terms in one bracket. So it will be e power x into derivative of root x, that is e power x into 1 upon 2 root x. I hope you have memorized the derivative of root x. The derivative of root x was 1 upon 2 root x. You can get it by that very formula of x power n. And also I had mentioned in the previous video that you should remember the derivative of 1 upon x also. That is d by dx of 1 upon x. By that x power n rule only, this will be equal to minus 1 upon x square. In case if you are not able to apply the x power n rule and evaluate this, do check out the very first video where I have discussed the first principles method, and I have discussed in detail the derivation of this result. Okay, so with that, let's just go ahead with taking the derivative. E power x into derivative of root x, that's the term I have written here, plus root x into derivative of e power x, that will be e power x only. So if you pull out an e power x term common from this bracket also, so you will have minus e power x into 1 upon 2 root x plus root x. At the most, if you want to simplify it further, you can just combine the two terms and you can write it as 1 plus, the LCM would be 2 root x. So you can write it as 1 plus, it would become 2 root x into root x, that is 2x. And yeah, this will be the final expression for the derivative for the fifth question. And yes, this is where I'm done with discussing all the examples based on the product rule. And I hope that whatever I've discussed in this video has been somewhere helpful to you in your preparations. Thank you for watching.